So these are the notes for 15.2. Again, our big topic here is triangles. And so our central question up at the top of the page, what are the special relationships among angles and sides between isosceles and equilateral triangles? Hopefully you've used these before and you know some things about these two terms that we'll get into more as we go along. An isosceles triangle, okay, the isosceles triangle theorem. If two sides of a triangle are congruent, so if they're the same, then the two angles opposite those sides are also congruent. So what that's saying is if I know these two sides are congruent, AB and AC, if those two are congruent, then the sides opposite that, and remember opposite means across from. And so if we have the side AB, the angle across from that is angle C. And for side AC, that's going to be angle B. Okay, so it's saying that those two angles will also be congruent to each other. So here we have a proof. So the proof of this theorem, it says given that AB is congruent to AC, prove that angle B is congruent to angle C. So again, our given statement is going to go here on the top. BA is congruent to CA, and that's a given. And our prove statement always goes at the end. And so we're just going to talk about kind of how this works. So BA is congruent to CA, that was our given. Angle A is congruent to angle A. So no matter what, that's going to be the same both times. That's called the reflexive property of congruence, saying that it can be the same as itself. So angle A is congruent to angle A. And then CA is congruent to BA. That's the symmetric property of equality. So it's just taking this first statement and saying, okay, if BA equals CA, then CA has to equal BA. Pretty straightforward, right? You can just rewrite it with it on the other side. That's called the symmetric property. Therefore, statement 4 says if I have these two congruent sides, I have a pair of sides, and in between I have an angle, then we can say that those triangles are congruent by side angle sine triangle congruence. So what we're saying here is that triangle BAC, which let me kind of clear some of that up for you. So triangle BAC, from B to A to C. So that triangle there has to be the same as the triangle from C to A to B. And yes, right, it's right on top of each other. So it's saying I have two triangles and they're pretty much flipped on top of each other. It's as if I took that one and flipped it over on top of it like a pancake. So those two triangles have to be the same because of side angle side. And so therefore, since those two triangles are the same, we can see that angle B, that lines up first, has to be the same as angle C, which also lines up first. And this right here, CPCTC, you've probably seen it before. Hopefully you have. You should have. Stands for corresponding parts of congruent triangles are congruent. And as you can see, that's exactly why we shorten that to that acronym. Okay, but it's just saying that each part of congruent triangles has to be the same. So, number 1, complete the statement about the converse of the isosceles triangle theorem. So I'm going to let you go ahead and do that one on your own. And that is the converse of this theorem right up there. Okay, the isosceles triangle theorem. If two sides of a triangle are congruent, then the two angles opposite the sides are congruent. So go ahead and write the converse right here down below. And if you have questions on that, you can ask me tomorrow, but you should be able to complete that by now. And then, secondly, we have a proof of the converse. So if we're going through the converse here, again, given angle B is congruent to angle C, so it's being a little more specific here. ABC is congruent to ACB, going the other direction. And so number 2, we would want to see that BC is congruent to, congruent to CB. Right, we know that those two lines are going to be the same. BC and CB are the same because they're the same line, and again, that's called the reflexive property when it's the same line. So if that's the case, we can say that angle ACB is congruent to ABC, again by the symmetric property. So ACB is congruent to ABC, so those two angles are congruent. Similar to the first one, right? That's just taking our first statement and flipping the two. And so step 4 says triangle ABC is congruent to triangle, in this case ACB. And we have two angles and a side. And we have an angle, a side, and an angle. So therefore, that is by the angle, side, angle triangle congruence. And then step 5, again, AB is congruent to AC. So AB, my first two letters here, AC, my first two letters here, means they have to be the same because of the really fun long one. Corresponding parts of congruent triangles are congruent. Okay, so it's saying if we know those triangles are congruent, then those parts, AB and AC, also have to be congruent because the entire triangle is. So those are the isosceles triangle theorem and the converse. So hopefully, again, you should have filled out the converse here, and we can check tomorrow, see how you did with that. Then on the next page, if you go ahead and turn the page, you will find the equilateral triangle theorem. So again, we have some definitions up here at the top. An equilateral triangle is a triangle with 3 congruent sides. Again, lateral is side. If you have lateral movement, if you move laterally, it's from side to side. And then an equiangular triangle, you'll notice the root word in there is angle. And so an equiangular triangle is a triangle with 3 congruent angles. So our equilateral triangle theorem says this: if we can tell a triangle is equilateral, then it is also equiangular. And so to prove that, we have a paragraph proof here. So given that AB is congruent to AC, so we know that AB is congruent to AC, we know that angle B has to be congruent to angle C. And that was by our theorem on the previous page, our isosceles triangle theorem. Triangles. It is also known that angle A is congruent to angle B by the isosceles triangle theorem, since side AC is congruent to BC. Therefore, angle A is congruent to angle C by substitution, our good old pal substitution. And then finally, angle A is congruent to B, which is congruent to C by the transitive property of congruence. So again, the big idea here, proofs, not necessarily super important, but just that idea that if it's equilateral, it is equiangular. Okay, if it's all three sides are the same, then all three angles are the same. And then similarly, I'm not going to go through this proof, but again, the converse to that is simply if it is equiangular, if all the angles are the same, then you know that all of the sides are the same. So on the next page, we have number 3. Katie is stitching the center inlay onto a banner that she created to represent her new tutorial service. It is an equilateral triangle, so all the sides are the same with the following dimensions in centimeters. So what is the length of each side of the triangle? Well, since we know that B is congruent to C, then the opposite sides are also congruent, meaning that AB has to be 6x minus 5. And since they all have to be equal, we can say that 6x minus 5 has to be the same as 4x plus 7, since those have to be the same length. And now we can simply solve for x. Subtract 4x from both sides. So we have 2x minus 5 equals 7. Add 5. Add a 5 to both sides. So 2x equals 12. And then x equals 6. Now, since x equals 6, we need to substitute that back in. So 4 times 6 plus 7 is 24 plus 7, or 31. And do we have any units? In centimeters. So go ahead and try solving number 4, and think about number 5, and go ahead and answer both of those, and we can talk about those tomorrow in class.